methods of analyzing business data, and then new innovative methods of analyzing business data, and what has to change, basically. So if I could just get kind of a read for the room, who considers himself fairly technical? Oh, good. All right, there's the hands. Okay. That means you can use Excel, right? Okay, who is pure business? No pure business. Okay, good. So we can geek out a little bit. Who's a student? No students either? Oh, one student. All right, welcome. And who is faculty? Any faculty? Who are you people? I got one faculty. Okay. Shout out, what do you do? Where are you from? Government administration. So that's not business, I guess. Right. What's that? Audits and government. Okay, cool. Cool. So the word governance in the context of this is kind of a misnomer. It's not government as governance as in like by the government, but it's governance as far as controlling access of your data. And I actually break data governance into 7 different components. And we're going to go over all 7. And we're going to talk about what it means in the traditional sense and what it means when you're dealing with big data or unstructured data or cool data. All right. So one thing is if you've been doing, who's been doing something to do with data for more than 5 years? Almost everybody. Wow. More than 10 years. Still a lot of hands. More than 20 years? Wow. Cool. Like 10 of you. More than 30 years. 1. All right. The sole survivor. Awesome. All right, cool. It's like being at the wedding, you know, everybody keeps dancing, right? Yeah, I'm on my 29th year. I started in 1986. So I've been through a lot of transitions going from mainframes to client server, from client servers to web, from traditional data modeling to dimensional data modeling, and from sequential programming to object-oriented programming. All of these are really, really major paradigm shifts in IT. And some people were able to make that leap, and some people weren't, right? And whenever there's a big shift like this, there is always going to be a change. And some people can adapt and evolve, and some people can't. So we're going to talk a little bit about if you want to stay relevant in IT today. And this is just purely, I guess, my point of view. But my point of view is purely on my experience and my observations through my clients. So I have a consulting firm in New York City that we do basically 3 things. So when you are at a pivotal moment in your company, in your enterprise, when you're going from, like one use case that we're working on right now, traditional cable television to being an online provider of content. Very, very different. Has to happen to stay relevant, right? The millennials are all cord cutters, right? If you're providing like TVs and movies and you want to stay relevant. My daughter is 23. The thought of watching a movie by appointment just blows her mind. She's like, why would you ever do that, right? She just opens up her laptop and watches it whenever she wants. So, so all of the companies that are in business that have programs by appointment, they have to change. They have to evolve, or they're probably going to die, right? So, so companies like that would hire my firm, and they would say, okay, this is what we need to do from a business perspective. What do we need to do from a technology perspective to actually help enable that? So we do 3 things. We do one is just strategy from a both business, organization, technology. This is what has to happen. This is what has to change. And then we do architecture and design. So this is what it has to look like in order for you to actually build this thing. And then finally, we actually build it. So we have implementation services that we do. All of the best practices that we follow come from this book, the Data Warehouse CTL Toolkit. Anybody in the data warehousing world probably has this book. It's been the best-selling book in the industry for the past 10 years, 11 years. And I wrote this book with Ralph Kimball. In 2004 it was published. Okay. So just a little bit of street cred. We, anybody see the name of their company up here? No? Okay. So traditional methods versus big methods. Since not a lot of people in this room have done big data methods, I just want to show that it's not hype, it's not future, it's here, it's now, it's happening. And I just go through a few use cases, very, very high level, and we'll peel back the layers of the onion over the course of the hour. But McGraw-Hill Financial, big data solution, Spark, Hadoop, integrated with their existing, and all of these, just by the way, big data, Hadoop, all this stuff is not replacing much of anything. It's enriching what we already have. So even though we're doing Hadoop, we're also still doing some kind of traditional relational database solution to, and then that together comes up with what we're calling the data ecosystem. So over the course of the hour, we're going to really focus on 45 minutes. We're going to focus really on how it all works together and how do we ensure governance with unstructured data and data that's not in your trusted relational data warehouse. Did it for McGraw-Hill, Bank of America, Hadoop solution, built a recommendation engine, also built a solution where we were ingesting data right off of their trading floor to help them comply with Dodd-Frank, the Dodd-Frank Act. And we were ingesting 1.4 million transactions every second. And we were in real time analyzing 8 different use cases, things like, is it a wash sale? Is it potential fraud? Is it more than 2 standard deviations from the norm of their peers? And we had 8 different use cases testing it. And then based on the outcome, we would either stop the trade, we would send an alert, put it in a report, what have you, right? So that throughput, there's no relational database and no legacy traditional solution that can do that type of throughput. So we had to come up with something pretty innovative, right? That particular solution we used for the technologists. We use Spark and Caserta. No, we didn't use Spark. If we're doing it today, we'd probably use Spark. This is about 3 years ago. We used Storm and Cassandra for it. Humana, built a data lake for them. Also about 4 different use cases. One of them, the most cool one that I think, is we were trying to predict and intervene if someone was a candidate for attempted suicide. So we're actually taking data out of their electronic medical records, looking at the free text in the doctor's notes, and looking for patterns for people who attempted suicide, and then try to find people with those same patterns who hadn't attempted yet, and try to intervene and try to save some lives. Pretty important stuff, very noble cause. I was very proud of that one. American Express, when they acquired Serve, which is electronic wallet to compete with PayPal, that was the first time they used Hadoop, and now they have about 6,000 nodes of Hadoop, and they control all of their analytics across the board. Domino's, they were using Netezza used for preparation for analytics. Took it off, and we put it into Hadoop. TE Connectivity, local Harrisburg company, built a data lake there using Cloudera. Where else? Warner Music. Warner Music, another very, very pivotal moment for Warner Music. Warner Music has been in business since the beginning of music. And, you know, basically music was like selling widgets, right? They would have research, they would have R&D, they would create a product called an album, they would sell it to retailers, right? Distribution, very, very traditional model. Today, it's completely turned on its head. Now they have no idea where their sales are coming from. The only way they know their sales is through data. And they're receiving data from streaming. Like iTunes, and there's about 140 different ones. And there's no standard whatsoever on how to receive that data. So every time they were 140 is beyond everyone's career here. So, so they needed a better way. So we helped them come up with a very dynamic way to ingest and analyze data before you structure it. And that seems to be the trend, and really the big reason for big data is that the thought of making a project to analyze your data or to profile your data, understand your data, structure your data, build a BI tool on top of it, and then give it to your users, that those days are kind of behind us now. We've been doing that for 15 years. We don't do it too much anymore because the time to value is just too long for the speed that businesses need to get to their data today. We're going to talk about a few use cases of those as well. HBO I already talked about. That's enough use cases. You get the idea, right? Okay. So lots of experience, and I'm just going to share everything that I tell you is just based purely on experience, no theoretical fluff. And I also have no products to sell. It's just purely concepts and practical experience. So another reason why I really like big data and the proof that it's now, actually I heard a speaker earlier talk about having sensors. I think it was James Serra in this room. He was talking about having sensors to figure out like what your blood pressure is and what your sugar is. And those electronic medical devices are happening today. Part of the Humana project was to do some of that as well, bring that, that electronic medical record, electronic medical device data in. But this guy, a guy named Chris Dancy, is a little bit psycho, but in a really, really good way. So what he did is he took every sensor he could possibly find, 700 of them, and he attached them to his body. Because he kind of thinks the way I think. It's 2015, right? We just had a meal, and we're going to have a meal tonight. When we eat, right, why do we eat? We should be eating for nutrition, right? But how come in today's day and age, with all the technology out there, we have no idea what we should be eating? Like, should we be eating protein? What is my sugar level? What is my B12? How much of that needs to be replenished? Like, we have no idea. We just eat because it kind of looks nice or it smells good, right? There's no science behind what we put in our body. And I think probably in our lifetime, definitely in our kids' lifetime, that's going to change. And this guy is trying to do that. So he found 700 different sensors, devices, applications, tracking services, and he's trying to be a completely data-driven human being, and they call him the Human Cyborg. And what I like about him is the way he looks at it, he says this data always existed, right, but we were never able to see it. That's the big difference between traditional methods and today with big data, is that what was otherwise invisible, now we have access to view it, right? And that's really, really compelling. So, understanding exactly, what is going in our body or going on in our body from a scientific and from a data-driven thought process, to me is pretty exciting, and I'm trying to help do that. I'm trying to focus the company a little bit on healthcare in general for personal reasons. I was a primary caregiver for my father, and he had this really weird disease, and nobody really understood it because there was no treatment, no cure, so therefore there was no data, right? If we could really start to capture data about things that were otherwise invisible, we can really start advancing. So that's why I have a very good passion for data. It's not just a job for me, and my company's not just a business for me. I really try to think about and approach different solutions being 100% data-driven in ways that nobody else could before. And I'm going to try to share some of those with you. So through the evolution of data and data analytics, this blue part is a Gartner thing. I didn't create it. But what I did is I tried to take it and explain it in plain English so we can understand what it is you're talking about. Hindsight, foresight, descriptive, predictive, that prescriptive, it's like, yeah, that's great. You sound really smart. But basically what we're trying to do is we're trying to go from just basic reporting of what happened to kind of correlating different events to figure out what is affecting something else, right? Are these two events really having impact on each other? And if they are, we can actually use one to influence the other, right? And we understand that the world works as an ecosystem. Everything affects everything else. So if we can use the data to actually help us do that, we can become smarter about everything around us, not just one single thing. So we went from reporting, which was just building reports on top of transaction systems. That's where, in the 80s and 90s. And then in the 90s into the 2000s, everyone was building data warehouses because data warehouses was the first time where you can take data out of your HR system and data out of your manufacturing system and do correlations, figuring out things like, do people from this school actually do better production, right, than people from this other school, right? Cross-functional analysis, attribution from one system, events from another system, and figure out if there's correlations. And we actually got pretty good at that. Most companies in the world have data warehouses, and most companies in the world could do predictive correlations now. The next step in the evolution is predictive analytics. So that's saying, okay, we know what happened, we know kind of what is affecting each other, but let's see if we can write some algorithms to predict based on patterns what's going to happen in the future. And there's tools out there like SAS and SPSS and a bunch of others. In the more modern engineering, there's Spark ML Lib, which is a library for machine learning algorithms. There's Spark has it. There's Storm. has their own Mahout in the Hadoop cluster. So there's no shortage of tools for this. But what's really cool about this university is teaching students and teaching people how to actually use these algorithms in the business case, right? Business scenarios. And that's really the magic, right? I feel like, just like programming, anybody could learn syntax, right? It's just like any other language. Anybody could write code. But coming up with a really creative solution from a business perspective, that's what makes you really special. And I think same thing with this. Advanced mathematics, anybody could memorize algorithms and figuring out what a linear regression versus logical regression, but when do you use it for which business case, right? And understanding that, and hopefully that's what's going on here. And I think most businesses are probably right around here, right? They have the correlations, they have the data warehouse, it's done pretty well. Now they're starting to figure out how to do predictive analytics. The thing that's interesting about predictive analytics is you need a lot of data, right? You don't need volumes and volumes, you don't need just mass quantities, but you need a variety of data, right? You need to figure out which attribution has statistical significance when you're trying to build these algorithms. So you need to have a diverse set of attributes when you're doing this to figure out, does being a smoker matter? Does your age matter? Does your region or your socioeconomic class matter, right? And the only way to prove these out is to do testing in your predictive analytics data science environment, which is starting to become the norm. And then after you get good at that, the next thing is to figure out not only are we going to predict what's going to happen, but we're actually going to make it happen. So we're going to do things like build recommendation engines and tell people, if you like this, you might also like that, right? And not only do it in like a really easy kind of pushy sales way, but in a very, very passive way. So if you have a customer that's in a shopping cart that just bought some food, and they typically, based on their buying patterns in the past, they typically get a brownie with their meal, right? There may be a subtle picture of a brownie in the background when they're checking out, and they may go back and actually buy a brownie, right? So we're not only just throwing data, but we're actually changing the experience of the customer, right, based on their past patterns and the patterns of their peers. And this is happening today in some of the more visionary, forward-thinking companies. What I think is next, right? This is happening, but not so much in like the traditional enterprise. But there are companies out there that are actually making making solutions that's based purely on cognitive computing and artificial intelligence. So this is the next step. So as we're becoming better and better at data, there's a whole different group of people, mostly on the West Coast, that's becoming better and better at machine learning and predictive analytics. And then the next step is cognitive computing. And this is, this is where I think it starts to get a little bit political and emotional, because once we can do this, once we can have the machines start to intellectualize what we're doing and start to make decisions based on things that weren't explicitly programmed, but things that it actually learned, right? Then when does the machine start replacing the human, right? And at what point does that happen? And that's a philosophical discussion that we could have over a glass of wine someday. Okay, so we're not quite there yet. We're not replacing our people with cognitive computing algorithms. What's happening today is that the businesses are changing. Businesses are becoming much, much more agile. They're receiving data that they've never received before, like electronic medical records and electronic medical devices and streaming music and streaming video and sensors off manufacturing plants and meters and, right, our phones, right, the geospatial technology. We are just getting so much data, and the thought of getting every piece of information you need entered by fingers on a keyboard is just, it's not happening anymore, right? So much data that we need today comes from data that we have absolutely no control over. So, SAP is here. SAP makes their entire, well, most of their living off of enterprise, ERP systems, where people are entering data into their systems, and then you do reporting off of those systems. So when you're building data warehouses off of something like an SAP ERP, it's a very, very, very controlled environment, right? And it's not easy, but it's a heck of a lot easier than when you have absolutely no control over your data. And so what's happening now is we don't have, how did that move? It's giving away my punchline. We have no control over this data that's coming in, all of the streaming data. So the thought of every time you want a piece of data, the business has a new piece of information and they want to do some reporting on it, some analytics on it. This is the life cycle that we all know and love, right? We interview the users, we figure out what they want to do with it, we do some data profiling, we create some data models, we code some ETL transformations, extract, transform, load. We apply data stewardship and data governance, business rules, data quality, put a BI tool on top of it, and then we develop reports. And nowadays, there's a 50-50 chance they may never use that data. It may not be that because what they're doing is they don't really know what some of this data is. If you're receiving data from a weblog, right, what's in that log? Like nobody really knows. So for IT to do it in a vacuum doesn't really work anymore. When you're receiving data from electronic medical records or from electronic medical devices, what's in there? Before we can do all of this, we have to do some data exploration. So that's really what's different about the enterprise today. We used to have to do all of these steps before we can analyze it. What we have to do now is we have to analyze it before we do all these steps. So thinking about it is very, very, very different. So a day in the life today, onboarding is very difficult, rigid structures and data governance. Somebody just wants to have at the data and see what's in there, right? So we can't make this a 3 to 6 month and 3 to 6, not only time-wise, but money-wise and investment-wise, right? And this latency is just unacceptable, right? It's completely unacceptable today. So what do we have to do? So what happens? So everybody's technical in here. Who's actually in IT and who's not? Who's in IT? A couple. Who's not in IT? Okay. Wow, most of you are not in IT, but you're technical. So that's awesome because this is going to be so true to you. So what happens is when you want to get at your data and IT says, okay, we need 6 months, what do? Typically what happens, statistically what happens, is you get a copy of it and you have a server under your desk, or lately you swipe your credit card on AWS and you build your own little environment. And we call these little shadow IT environments, right? And you maintain it yourself. Everybody's nodding. The entire room is going like this. Yeah. This is a major, major, major problem. And this is even before most of this is like really taking off. Like this is happening, but it's not running our life yet. It's going to be running our life soon. So the thought of needing to get to our data faster in a more controlled way has to happen, because otherwise, this is what's happening. So everyone is just taking their own version of the data and copying it. So there was a statistic back when big data first started to say that IBM said that 90% of all of our data was created in the last 2 years, right? Which is pretty astounding. But after reading these stats, I wonder how much of it is like net new data and how much of it is just copies of the same data, right? And I think something has to change eventually. For now, we just have to learn how to deal with it. But, if you think about it, like how many copies of like the ingestion of the Twitter fire hose do we really need in this world? Like everyone is just copying it down to their own data set. At some point, I think the way we deal with data is going to change, where we'll probably be 100% API driven and you just get data wherever it comes from. But for now, we're taking our data and we need to put it in a place where it can be controlled throughout the environment, but it can't be so heavy-handed that it takes so long and it's so different from the original raw data set, especially if you're trying to do machine learning. Any data scientist, IT goes through such heroic efforts to make the data structured and easy to navigate. But the average data scientist just wants raw data. They hate when you manipulate their data, right? They want it raw. So what we're doing, and they're saying this is a $44 billion problem, and copies of data consume 60% of all of the disk space in the world. Just a quick stat, 43% of the companies in I think the world, if not the country, are doing something to significantly simplify the information that they have. And the other 37% are planning to do something about it. So this is what's changing. We have to go from structure, ingest, analyze to ingest, analyze, and then structure. And the easiest way for me to do this is to build a data lake. So a data lake is an environment that is not heavy-handed and not fully governed and not so structured. It's a place where we can ingest data in its raw form, put some light data governance around it, and let trusted users like the data science team have at it. And we're going to talk a little bit about what that might look like from an architecture perspective. So I'd like to, there's so much fear around big data and this so all ungoverned, The thing that's interesting is all of those shadow IT servers that you have under your desk, which probably half the room raised their hand and said they already have. The first question was, are you dealing with big data? Nobody raised their hand. So all of that shadow IT data is totally ungoverned, right? Nobody knows you have it. Nobody knows what's in it. There could be PII. There could be PHI. There could be credit PCI. Could be all kinds of information. Nobody knows. There's no controls. Nobody knows who's accessing it, when they're accessing it, what's in it. So the data governance is not a big data problem. Big data, I think, is actually the change agent to try to improve the issues that already exist in every environment today. Okay. So this is just a graphical of what we've been doing for the past couple of decades, getting data out of these highly, highly complex ERP systems and transaction systems, bringing it into a traditional data warehouse, fully structured, lots and lots and lots of ETL. Made most of my career writing that ETL. Master data management, data governance is all enforced there. And then eventually we get to write some reports and some ad hoc reporting. Right? That's the way it was. But now we have all of this information that we don't know what it is. Right? The thing that was interesting here is that we controlled this. So if we wanted to profile it, right, and we wanted to quality assess it, it was very, very easy to do, right? We just look at it in place, and we run our queries and figure out nullability and mins and maxes and dates out of range and like all that stuff, right? Very easy. Do we have claims without policies, right? All the business rules, easy to do. Here, we're getting data from social media, from Internet of Things, electronic medical records, web logs, no control. We don't even own it. We don't know what it looks like. So how do we build data models for it? How do we do data quality assessments for it? It just really can't do it. It's impossible. So the only way to do it is to build an environment where you can do this type of analysis. And that's the data lake. Typically it's Hadoop. It doesn't have to be Hadoop. The thing that's nice about Hadoop is Hadoop doesn't care about the structure. If all this information comes in different structures, you just bring it into Hadoop, it doesn't care. So once it's in Hadoop, then we could do analytics on it. Then we could figure out if there's any value in it, and if not, we throw it away. And if there is value in it, then we can go ahead and structure it and put some quality assessment on it and monitoring and governance. And then we can do reporting. Where's the reporting? And there's the reporting. So I guess one would ask, if we can get all of our data into the lake, and then we can run reports out of the lake, do we actually still need this top swim lane? Right. For now, we absolutely do. Because for now, at least in my experience, down here never becomes fully 100% governed. Right? It comes close, but it's not fully governed. If you want fully governed data that you can actually like report to Wall Street, right? or report to your shareholders, it has to go through a rigorous data governance process, be fully structured in your data warehouse, and then you can run reports out of there. Now, but that evolution is still evolving. So having a fully structured environment where you can do arbitrary queries in a controlled, governed manner, this is getting better, right? There's products out there, like if you're using Cloudera, they have Impala, which is a pretty structured, robust environment. It's basically an MPP data warehouse, just like Netezza or Teradata, but only it sits in Hadoop. So the evolution will happen, but for now, physically, it's in a separate place. Right? And we're going to talk logically what it looks like and how to get the data from one place to another. So innovation is the only sustainable competitive advantage a company can have. And when you're doing these innovations, when you bring these data sets in and you try to do some insight, some data science on it, there could be that it's a fail, right? And that's okay, right? And it's okay to fail when you're doing innovation. But if you don't do any innovation, you will definitely fail. So that's why if you're going to fail, you want to fail really fast before you invest a lot of time and a lot of money. So that's why this whole data lake paradigm is becoming so popular, because it's a very, very easy way to just have out your data with not a large investment. This is where you're supposed to laugh. So, recreating the wheel. Taking what you have in existence today as far as people, process, and structure, and forklifting it over to Hadoop is not going to change anything in your environment. You're not going to be any more innovative than you were before. You're actually going to be less innovative, because a lot of the things that we do today, especially when it comes to control and governance and structure, Hadoop doesn't do that well. So it's actually going to be very, very painful. So understanding exactly what Hadoop is good at and what it's not good at is critical, and structuring your Hadoop cluster, which looks nothing like the way you would structure your data in your relational database. Understanding that architecture is really important. I'm going to talk a little bit about that, but not go into too much gory details about that. So, how are we doing on time? Oh, we're good. Okay. So I just want to talk technologies. Anybody familiar with AWS, Amazon Web Services? So Amazon Web Service, moving your data to the cloud, that was the other big scary thing in life, right? I can't put it on the cloud, it won't be safe. Actually, people are starting to realize that putting it on the cloud is actually safer than having it on premise. And I heard it best by a guy actually in the media industry. He said, you know, we're a media company, and we have a department that is responsible for securing our data, right? And we do the best we can, but it's just a couple of people. Where Amazon, that's all they do. Like, their budget for security is larger than the entire IT budget for this company, right? Probably the entire company's budget in general, right? They're investing millions and millions and millions of dollars. And more government agencies, CMS, who controls Medicare data, is now on AWS. So as you know, the more thought of as like secure environments are moving to AWS, everyone else is just lining up. This year, 50% of our business is out on AWS. Once it usually starts as a small POC, but once people see the economics of it, it's just people are going over like wildfire. The other thing that's really cool about AWS, I'm not pushing AWS, I'm just sharing my experience, the elasticity aspect of it, where in the data warehouse world, you would have to figure out, okay, so how much data do we have today? How much data are we going to have in a year? How much data are we going to have in 3 to 5 years? And let's buy that capacity so that we can grow into it, right? You don't have to think like that anymore. Now we stop after how much data we need today, period. And then as we as we get more data, then we could easily expand what we have literally with a couple of clicks, within minutes, maybe an hour, right? But it's not, you're not throwing anything away, you're not buying a new appliance, you're not going through a big procurement and installation and configuration and data center cages, like all of that is gone, right? So most companies, most of our clients, they want to get out of the infrastructure business and they just want to do data analytics. And this enables them to do that. The other thing that's really cool, scalability, right, is not only about getting big, it's also about getting small. So being elastic is very, very important to a lot of our clients. So like, for example, Warner Music, when Bruno Mars released that song, what was that song? Uptown Funk, thank you. Uptown Funk, oh, and I wish I had the stat handy. I had the stat written down somewhere. But it broke all kinds of records because I guess when a song is first released, if they get like 200,000 downloads, it's a lot. I think he got like 20 million downloads, right? So what they had, we helped them build, is that as you're running your processes, as you're ingesting this data, you're actually building the nodes that you need to process this data as you go. So as you're streaming the data in, you're building your nodes. So you can build it just in time, and then after you're done with your process, you can shut them back down. So you're only paying for them when you need them, right? Can you imagine if they said, okay, if any artist can have 20 million downloads in a day, we have to prepare for that and be, right, the investment in that for something that might happen once again, right? And to be prepared would be incredible investment, incredible waste of time and money. So the elasticity is a really, really important part of being on the cloud. The other thing that's really cool about the data lake is a notion that we came up called tunable governance. So we're going to talk about how you use tunable governance to prevent your data lake from becoming a data swamp. So when we think about this, right, any CDOs in the room? Any companies that has a CDO? A CDO is a Chief Data Officer. It's actually a new position that's being created. It started just a few years ago. And I spoke at MIT earlier this year. It was specifically for CDOs. And I think they said that the count today in the United States is about 384 CDOs across America. So it's a pretty small number, but it's growing every day. There's more CDOs being created all the time. What a CDO is trying to do, so the reason CDOs are born or created is because data is becoming so critical that they need someone at the executive leadership level responsible for this data and getting insight out of this data. So the CDO quandary is that they're responsible for keeping the data secure, right? If there's a breach, they're the guys who walk out in cuffs, right? So they have to make it secure, but they also have to make it easily accessible so that the data science team can have early access to it. They have to ensure quality, but it has to be instant delivery. So all of these contradict each other. So we came up with this notion of the CDO tightrope. CDO tightrope means that we need to apply governance, but we need to really understand what it is we're governing and what is the use case for it. So if a data scientist is just munging data to figure out if there's any value in it, does it really need to be as governed as something that's a final report that may go to Wall Street? We're saying no. Right? So what we're trying to do, not only help companies from a technical perspective, but help companies with the data governance side and the legal department, because typically what happens, especially in like healthcare and government, if you're in that, if that's your industry, is that every piece of data has an allowed use, right? And if you think of a new use for that data, you have to get approval before you can actually do it. So what we're trying to help companies do is make data exploration an allowed use. So you can explore it, you can find out if there's value in it, but you can't really do anything in production with it until you go through the proper data governance channels. So I'll tell you how we actually do that. So we have 7 different components. Data organization, organization, that's the people part. Metadata, privacy, data quality, business process integration, master data management, and information lifecycle management. And business process integration, we kind of jumped over for a second, but I want to show it to you. So on this slide, see this little blue line? The blue line is actually connecting your production systems to your analytics platform, right? In the old school data warehouse world, we used to call that closed loop, right? Where the data in the data warehouse became so pristine that it actually became reference data for our production systems. That was like, if you did that, it was like data warehouse nirvana, right? It was a really, really, it was an accomplishment. But now, since the applications actually needs the insight from the data science folks, things like recommendation engines, and what is the propensity for this customer to actually buy something, right, depending on its behavior patterns. This is actually becoming more the norm, right? Having the analytics platform part of the back end of your application is becoming more and more natural. So really understanding business process integration between your analytics and your production environment is really more critical than ever. And then information lifecycle management is just, once we get it, how long do we need to retain it? Once we have it, do we have to purge it, depending on our regulatory requirements? All of that still needs to go in play. When we're dealing with big data, just about every component in the data governance area has to change to some degree. So for organization, we have to enrich our data stewardship. Data stewardship has to bring in data scientists, because the data scientists are the only ones who really understand this new data, right? So we have to get them on board to help us govern it. We also have to get people who are specialists in the external data that we may be receiving, things like Twitter feeds and Facebook and social media, call center logs, right? If there are people who understand that data, they should be brought into the data stewardship organization. Metadata is changing, using Hive. Hive as a access method in Hadoop, I think is probably one of the worst things you could possibly do. But from a metadata perspective, it's probably one of the best things. For native metadata capture in Hadoop, the Hive Metastore in HCatalog is probably still one of the better ways to go, besides having external third-party products. In the Hadoop environment, there's a product called Waterline, probably one of the better tools out there for capturing metadata. Privacy security, I don't want to go over these too much because we are running out of time, but let's go to here. So the big data pyramid. So this is what I came up with, that those dozen or so examples of those clients, we've implemented these in all of those. So we basically break up our data ecosystem into 4 layers. And sometimes this middle layer, these 2 layers could be thought of as a single, but it's really 4 distinct use cases. So the left-hand side of this is the usage pattern. So what do you do with this data once it's here? And then the other side is how much governance do we have in the tier? So the bottom layer is just purely for landing. So anything we receive in its raw form, sorry, my New York accent, it stays here. And we can always go back for auditability and traceability to figure out where our data came from and what it looked like when we received it. It stays here. From here, we bring it into the data lake. Now the data lake starts to organize it a little bit, starts to get more definitions. We apply metadata. We know information lifecycle management and security from down here, but we start actually putting it into a data catalog, because the biggest challenge with big data is you can store it, right? Disk is cheap, all that nonsense, but finding it, right? That's the challenge. So data cataloging is a whole new category that is really more important than it's ever been, and there's a few products that I'll share with you in a minute that do it pretty well. But truth be told, it's an evolving, maturing category in the data space, and there's a lot of room for growth and a lot of room for innovation. So we have the data lake. Hanging off the data lake, we have these data science workspaces. The data science workspaces are what we call ephemeral. And what that means is we create it just long enough for them to do their science, After they do their science, if it has value, then it goes through a promotion process. If it doesn't have value, it gets thrown away. And that kind of stops this area from becoming a junkyard. And it actually forces them to get on board with the data governance program. In order for them to actually take the science and apply it to production, they have to go through a rigorous data governance process. So they can have at their data and do their science pretty lightweight without a whole lot of heavy-handed governance. But in order for their insight to be used, then it has to be fully governed. Wish I had a clicker. So we call this the data refinery. So basically what happens, we get cool new data. It goes into our data pyramid. And then we also have the concept of late bind analytics. So what that means is that we're not persisting data here and then a new version here and then a new version here and then a new version here. Late bind analytics, it's almost like if you're familiar with relational databases, you have a bunch of tables, but it may be joining those tables and doing calculations is very cumbersome. So you create a view on top, and it's fully dynamic, right? And when you say select star from this view, it actually executes a bunch of code that makes the data easy to access, right, on the complicated data underneath. Late bind analytics is almost like the same thing. So you can actually have views in here that's actually reading your source data. So it's fully unstructured still, but you can make it look somewhat semi-structured at least, so you can do analytics on it. And then you're just basically dropping those views when you don't use it anymore. If you do want to promote it, you can either put it back in the lake for future use, for future insight, or you can run it through into what we call the big data warehouse. The big data warehouse is the little piece on the top that's still fully structured, fully governed, and can be outside of Hadoop, can be inside Hadoop. Am I out of time? Okay. It could be something like Teradata Netezza, or it could be Impala. I just want to go to some of the tools, because I know you guys love tools and logos. So this one page is actually almost the end. So traditional stuff that we've been doing, Informatica, Talend, SAP, Oracle. A whole new set of tools are being born. Trifacta, Paxata, Actian, these are all good data integration tools. For data governance and data cataloging, Global IDs, I think they're based out of New York. Waterline, Calibra for data dictionaries, business glossaries, and then some of the new emerging technologies. Apache Atlas is kind of the data governance for Hortonworks offering. Navigator's Cloudera's offering. Tamr, machine learning in order to do ETL, created by a guy named Stonebreaker, Michael Stonebreaker, very smart guy. Teradata uses Loom, which is their data dictionary. And Elation, I think, is one of probably the most emerging innovative technologies out there for end-to-end data governance on big data. And then CCAN is actually open source. And if you were to go to data.gov.uk and get all of the data from the European government, that whole experience is using CCAN for data exploration and data cataloging. People, business, and processes still as critical as ever, and that's it. Thank you.
We have time for about a minute of questions.
Cool. I'll talk fast. Any questions? No? Not one? Okay. All right, thanks. That's my contact info if anybody has any questions, but too embarrassed to raise your hand, feel free to reach out. I'm very friendly, very approachable.
Thank you so much.
Yeah, my pleasure. Yeah, thanks.
Could you flip it back to that define slide?
Which?
Thank
This?
you.
Oh, yeah. Yeah, there are tools out there, while people are getting up, there are tools out there that actually will scan your entire network and find your data. So all of those shadow IT little servers that you have, it'll actually scan your network and find all of your data. And you can actually identify what's PII, PHI, and it'll help you detect your vulnerability. And it'll put it all in a catalog for you. And then you can use that to help prioritize sunsetting some of that stuff.
What kind of what software do you know of that does that?
These in the middle. Global IDs does it. That's probably, Tamer also does it. And Tamer is actually free. So Tamer, they'll give you could just go download their data catalog and do it for free. And then they hope that you buy their data integration software. But you don't have to. Sorry? ETL? Extract, transform, load. So when you take data out of one system, you manipulate it and prepare it for analytics, and you put it into another system. And then you can analyze it. Okay, thanks. Oh, sorry. This one?
Yeah.
Yeah. Is there somebody right behind me? No. No?
Next session, just one more session.
Oh, okay.